Good morning. Today I'm just gonna show you guys how to graph y equals sine of x and sort of give you an explanation of why it takes the shape it does. So let's get started. I'm gonna be using a few tools in the process here. First, the 30, 60, 90 triangle, um, a little bit of the 45, 45, 90 triangle, as well as the unit circle, which is gonna be quite useful, and I'll tell you why. Because the unit circle can tell us the values for sine, cosine, and tangent really easily at 0, 90, 180, 270, and back at 360 degrees. And we can just use the points here. So let's say this point right here is going to, on the unit circle, is going to be 0. Oops, actually it's going to be 1, comma 0. This point is going to be 0, comma 1. That point right here will be negative 1, comma 0. Actually, let me just not make it as messy. Negative 1, comma 0. And this point right here down below is 0, comma negative 1. Okay. And the value of sine is always going to be represented by the y value right here. So at 0, sine is going to be 0. And our ticks here are going to go from 0 to 90 to 180. Each tick is going to represent 30 degrees. So let's get started right here. As I already mentioned, sine of x, the value of sine of x is x. If x is 0, is going to be 0 because of this guy. So it starts right here. Then, up at 90 degrees, sine is going to be equal to 1. So let's say, 1 is going to be here. But what about in between? 30s, 45, and 60 degrees. Now I can use the the units, the special triangle of 30, 60, 90 to figure out the shape of the sine function. And for 30 degrees, sine is SOHCAHTOA. Sine is opposite over hypotenuse. Sine of 30 is half. So 30 degrees, we have half right here. Then at 45 degrees, just to give you guys a general idea of what it's going to look like, we have sine of 45, 1 over root 2, which works out to be approximately 0.7. So that's somewhere over here perhaps. Then for 60 degrees, we have root 3 over 2, which is 0.86. So approximately here. And so the shape of the sine graph will look like somewhat like this. Oops. That's looking kind of terrible, isn't it? I hope you guys get the overall idea. That's the most important. Okay, so what happens with the sine graph after that? When we go back down to 180 degrees, sine is going to be 0. And the shape is going to be just the exact same. It's going to be the mirror image of this first part. So it's going to look like this. Then, as we go back down to 270 degrees here, sine is going to go down to negative 1. So this is 180, that's 270. So it goes down to negative 1. And it's also the mirror image as we go down here. So it's going to look it's going to look approximately like this. And then sine is going to go back up from 270 and negative 1 up to 360 and 0. So right there. And we have graphed a full period of y equals sine of x. Of course, the sine of x keeps repeating, and it goes on forever this way and that way also. And it keeps on going up and down. So hopefully that gives you a good idea of why this sine of x graph looks like this. And you can take a look at the website for more similar questions, including graphing questions, right here. So, oops. Yeah, thank you for watching, and hopefully that made great sense. Thank you.